Alright guys, so yesterday we learned how to solve systems of equations by graphing. And as we spoke about it yesterday, I'm sure you realize that graphing is not always the most efficient method of solving. So we do have algebraic methods for solving systems, and we have two. Today's lesson is going to be on substitution, and it sounds exactly like what it is. It's substituting something in for something else. Okay, so there are 5 steps to use substitution. Our first step is to choose one of the equations and solve for a variable. And notice they give us a hint here. Choose a variable with a coefficient of 1 or negative 1. So what that means is, if you look over here at these two equations, we have 2x and y, 2x and 3y. The number in front is the coefficient, if you will recall. So this coefficient is a 2. This one is understood to be a 1, a 2, and a 3. So when we are solving this, we want to be very particular in the equation we pull to the side. Now, quite frankly, you can solve either of these equations for any of the variables. However, if I was to select to solve for this 3y, I would end up with fractions. I'd end up with negative 2/3 and 8/3, which, while they're not terrible numbers, they can be a little messy and they can cause us to make more simple mistakes. So instead, I'm going to pick this y up here, and I'm going to get it by itself. I'm going to isolate it. So to do that, I'm going to pull this equation out to the side. So 2x plus y equals 6. And we're solving for y, which means we need to take and subtract 2x from both sides. So think back to our little equations. Think back to solving for y. Y then equals negative 2x plus 6. So that's step 1. All right, step 2 says that we need to now substitute the expression from step 1 into the other equation. So what that means is we're going to take this equation and we're going to plug it into this bottom one that we didn't use. And what we're going to plug in is wherever there is a y, because that's what y equals, we're going to plug in negative 2x plus 6. So to do this, we're going to rewrite the expression 2x plus 3, but instead of putting a y, I'm going to put parentheses because I'm going to substitute that in equals 8. And what I'm substituting in is going to be negative 2x plus 6. So now this is a simple linear equation, and we're going to sit here and we're going to solve it out. So the first thing we have to do is we have to distribute. 3 times negative 2x is negative 6x. 3 times 6 is 18. And this is going to equal 8. Now our next step is to find our like terms. So these right here are our like terms. So 2x minus 6x is negative 4x plus 18 equals 8. So now we're back down to a two-step equation. Subtract 18 from both sides. Negative 4x equals negative 10. And divide both sides by negative 4. So x equals positive 5/2, or you could say 2.5. Okay, so now we've solved for x. That was only step 2. So now our next step, if you look over here, says that we need to substitute the value. So this value that we just got, we're going to resubstitute this back in to the equation we found in step 1. So the reason we're going to do it this way is because this is already solved for y, which makes the problem a little bit easier. You could substitute up here in the original equations, but if we're solving for y and this is already solved for y, why wouldn't we just plug in? So we're going to have y equals negative 2. Again, we're plugging in a value for x, and this time our value is going to be 5/2. So right in here, we're going to plug in 5/2. So that's going to give us y equals negative 5 plus 6. And negative 5 plus 6 is 1. Now, our fourth step says that we need to write our solution as a point. So, and notice it also says it needs to be in alphabetical order. So X comes before Y, and the reason it's alphabetical order is because sometimes we don't use X and Y. Sometimes we use M and P or A and B. We use all kinds of letters. So when we don't have X and Y, we do alphabetically. So this point would be 5/2, comma, 1. You must put parentheses around it. It is a point. Okay, and that would be our solution. Now, our final step says that we must check our solution in the original equations. Okay, that's particularly important. If you check your equation in step 1 here, you might think you did it correctly, and really you maybe solved that wrong and then you have the wrong answer, but you won't know until you go back to the original. So we're going to take that original problem and we're going to check it. So I'm going to have a little check spot right here. So we're going to take and put 2 times 5/2 plus 1, and we want to know, is that 6? So this right here is 5. 5 plus 1 is 6. And then we're going to take our second equation, 2 times 5/2 plus 3 times 1. Is that 8? Well, 5 plus 3 equals 8. So check. So since both of them checked, we know that this answer is good. So we can box our answer and we can say we're done. But if it did not work in both of these equations, I would want to go back and recheck my work and make sure I didn't make a mistake. Okay, so let's try another one. So number 2, we have x plus 5y equals -5, and we have 4x minus y equals 1. So first decision we have to make, which variable do we want to solve for? Okay, so if you look here, the x has an understood coefficient of 1, and the y has an understood coefficient of -1. So if you were working this problem yourself, you would have a choice to either solve for x or y. Now, I'm going to solve for this x right here, and the reason I'm going to solve for x is because it has a coefficient that's positive. If I don't have to work with a negative, that means I have less room for error. So I'm going to pull x plus 5y equals -5 out to the side, and I'm going to solve for x, which means I've got to leave the x right where it's at, and to do this I'm going to subtract 5y. So x equals -5y minus 5. And it really doesn't matter which order you put them in. You could say -5 minus 5y, as long as you have the entire expression there. Once the x is by itself, we're going to plug it back into the equation we didn't use. So wherever there is an x, we're going to plug this expression right here. So that means we're going to have 4 times some expression minus y equals 1. And again, that expression is -5y minus 5. Just as before, we're going to sit here and we're going to distribute this out. So -20y minus 20 minus y equals 1. Collect our like terms. So -20y and -y gives us -21y minus 20 equals 1. And then just solve it as a two-step equation from there. Add 20 to both sides. So -21y equals 21. Divide by -21. So y equals -1. So now we've got to take this. We're not done yet. We're going to take it all the way back up to the top and plug it in where the y is. So x equals -5 times -1 minus 5, which means x equals +5 minus 5, which of course is 0. So our solution right now is 0, -1 as a point. And then of course we want to check it. Okay, the great thing about this section is that you can check every single answer and know if you've got it correct. So is 0 plus 5 times -1, is that -5? Well, -5 equals -5, check. is 4 times 0 minus negative 1 equal to 1. Well, that's true because 4 times 0 is 0. Negative times a negative is a positive. Check. So that means this answer right here is correct. 0, negative 1. All right, number 2. So this time, this problem is one that trips students up a lot, and it's actually a fairly easy problem. We have a equals 2b plus 6, and we have a equals negative 3b plus 16. Now, this one, half the work is already done for us. Both of these are already solved for a, which is particularly nice because that means we don't have to do that extra step. So we have to make a choice. Which equation do we want to pull out to the side? You can pull the top, you can pull the bottom. It really will not matter. Since we've not pulled the bottom equation out yet, let's do that one this time. So I'm going to say a equals negative 3b plus 16. It's already solved for a. So what that means is I'm going to take this expression here, this negative 3b plus 16, and I'm going to plug it in right there for that a. So basically I'm just setting them equal to each other. So that gives us negative 3b plus 16 equals 2b plus 6. Now you don't need the parentheses there. You can put them if you want them, but they're not necessary. And now we just need to solve this. So this time our like terms are on opposite sides. So remember, that means we need to subtract to get them on the same side. So negative 5b plus 16 equals 6. Subtract 16 from both sides. So negative 5b equals negative 10, and divide by negative 5. So b equals positive 2. Again, don't stop there. Take it all the way back up to this expression up top here. A equals negative 3. We're going to plug the 2 in right there. And then we're going to have plus 16. So a equals negative 6 plus 16, which means a equals 10. Now, this time we don't have x and y, so that means we have to go alphabetical. A comes before b in the alphabet, so you're going to have 10, 2. And as always, we want to check our answers just to make sure we've done it correct. So, again, we have a, and then we have b. So does 10 equal 2 times 2 plus 6? Well, that's 4 plus 6, which is definitely 10. So check. So then our next expression would be, does 10 equal negative 3 times 2 plus 16? Well, negative 6 plus 16 definitely equals 10. So this answer is correct, and we can move on. So I'm going to give you number 3 to try now. So number 3 is this expression right here. So what I want you to do is I want you to pause the video, and whenever you're ready to check your answer, you can turn it back on. All right, hopefully you're ready to turn the video back on and see your answer. So number 3's answer should be negative 2, 10. So x is negative 2 and y is 10. Now you're going to notice that I actually solved for the variable y. Whoops. Right here. If you solve for x, it doesn't make it wrong. You should get the same answer. It's just that your work over here is going to have y equals 10, and then you'd have to plug in and get x. Now, if you didn't get the right answer, go back and check and see if you can figure out what you've done wrong. If you can't figure out what you've done wrong, then put a little circle so that you know that you need to ask your teacher about number 3 tomorrow. Also, if you did not do the check, then that's not a good habit. You need to get in the habit of checking your answers. You should be able to make a perfect score on a test or quiz, and you should be able to know as soon as you walk out the door whether you did or not. And also, don't get into the habit of just checking to show the steps. Actually make sure it does work. Does negative 2 plus 10 equal 8? It does. Is negative 6 plus 20 really 14? Yes. Okay, so let's try number 4. So again, I'm going to let you try this one. So the problem is negative 5h plus 7j equals negative 3. So 3h is the next one, minus j equals negative 11. So I want you to take and I want you to solve this system. Pause the video. When you're ready to turn it back on and check your answer, then do so. All right, so hopefully you're ready to check number 4. So number 4's answer is negative 5, negative 4. So let me just kind of jump through what I did really quick. Now you really didn't have much choice here. The best variable to solve for was this yellow j right here because it's the only one with a coefficient of 1 or negative 1. Again, if you selected one of these others, it will work, but you're going to be working with much nastier numbers. So notice when I solve for j, I end up with 3h plus 11. So now plug it in for j, and when I solve for h, I get negative 5 using my algebraic equation skills. Then plug h back into j, so right there, so it's 3 times negative 15 plus 11, and then that gives you a negative 4 for j. And then of course alphabetically h comes before j, so h comes first in the point and then j, and then as always you should have checked. So make sure you have this one correct. If you have any questions, make a note to the side to ask us about it on tomorrow. Okay? So let's try number 5. So number 5, the equation is x minus 5y equals 2 and negative 3x plus 15y equals 5. So again, this one's pretty straightforward. The best equation to solve for would be this x right here. So that's what we're going to do. I'm going to pull the top one out to the side. X minus 5y equals 2. Solve for this x right here by adding 5y. So x equals 5y plus 2. So now we're going to take this expression right here and we're going to plug it in for this x right here. So that's going to give us negative 3 times something plus 15y equals 5. And that something is going to be 5y plus 2 because that's the highlighting that matches. So now distribute negative 15y minus 6 plus 15y equals 5. Combine our like terms. Now you're going to notice when I combine negative 15y and positive 15y, that equals 0. There's no y's. So what that means is we end up with this negative 6 equals 5. And if you recall back to our special solutions back in chapter 3, which was equations, negative 6 does not equal 5. And since it does not equal 5, that means this is a no solution. So those special solution sets happen in systems as well. These equations are never going to intersect because there actually happen to be parallel lines. Okay, they're actually going to have a slope that is the same with different y-intercepts. So we simply put no solutions. Now we can't check this one because there's nothing to plug in, but you could check to see graphically if they are parallel lines. So you could always use your calculator or you could do a quick sketch and check their slopes and their y-intercepts. All right, let's try number 6. 4x plus y equals negative 20. 8x plus 2y equals negative 40. So again, not much choice here. We're going to solve for this y because it has the coefficient of 1. Pull it over to the side. 4x plus y equals negative 20. So we're going to take and we're going to subtract 4x from both sides. So y equals negative 4x minus 20. Now again, we're going to take and we're going to plug in for y, this right here. So we're going to have 8x plus 2 times that y equals negative 40, and that y is negative 4x minus 20. Distribute. So that's negative 8x minus 40 equals negative 40. Again, combine our like terms here. So that again equals 0. We don't write the 0. So that means we end up with this negative 40 equals negative 40. And negative 40 always equals negative 40. So, as you've probably guessed, the solution to this system is all it's not all real numbers this time. It's actually going to be infinitely many solutions, but we have to be very specific. So it's infinitely many solutions on the line 4x plus y equals negative 20. And it really doesn't matter which one you select because these are both the exact same line. If you were to graph these, graphically they would have the same equation and they would lie right on top of each other because they intersect at infinitely many points. So this right here would be our solution. Now notice I didn't say all real numbers this time. All real numbers is when you're talking about solving for x or just solving for y. This is actually infinitely many points. So that's why we say solutions. So the solutions are going to be a point and they're on this particular line, so x and y. All right, number 7. We're going to write the system of equations represented by these tables, and then we're going to solve. So remember, to write a system, or to write an equation of a table, you need two things. You need a slope and a y-intercept, or a slope and a point. So first thing we're going to do is we're going to look at table 1 here, and notice right off the bat I can see the y-intercept is 0. Now the slope, let's count it. We got to do change in y. So that means we're going to be adding 4. This one's adding 6, adding 2. And then on top here, we're adding 2, adding 3, adding 1. So our slope here is 4 over 2, which is 2, 6 over 3, which is 2, and 2 over 1, which is 2. So our slope for this first equation is m equals 2. So what that means is our first line that we're going to write is y equals 2x. And if you want to put plus 0, you can, but the y-intercept is 0, so we really don't need to do that. Okay, so for the second line, I'm going to erase this stuff right here so I can work with it. We can't see our y-intercept, so we're going to have to pick a point, but we can see our slope. So we're subtracting 2 on the change in y's, and our x's are adding 2. So that means our slope for this second box, the second table, is going to be negative 2 over 2, which is negative 1. So y is going to equal negative 1x, but you got to find the y-intercept. So if you remember, if you know a slope, and if you know a point, such as 1, 5, you can pick any of those points, we would have y minus 5 equals negative 1 times x minus 1, coming right back to point slope. So y minus 5 equals negative x plus 1, and then add 5. So here, y equals negative x plus 6, and that's logical because 6 would fall between 7 and 5, as would 0. So that means our y-intercept here is going to be plus 6. So now that we have our system, I want you to take a moment and see if you can solve the system. When you're ready, turn the video back on, see if you got it correct. Okay, hopefully you're ready to turn the video back on. If you're not, put it back on pause. About to show you the answer. So the answer to this problem is 2, 4. So that's what we should have gotten. It doesn't matter, again, which equation you pull out to the side, as long as you set them equal to each other because they're both solved for y. And then you should get x equals 2 and y equals 4. Again, you can check it to make sure. You could actually extend your table and see if those values match up on the table. If you were to graph these lines, that's where they would intersect. Okay? So number 8. So one of our favorite things to do, which is our word problems. So number 8, for Valentine's Day dance, tickets for couples cost $12. That sounds a little important, so I'm going to highlight that. Tickets for couples cost $12. And tickets for individuals cost $8. Again, sounds a little important. It says, suppose 250 students attended the dance. All right, so we have a total. So we have 250 students that attend, and $1,500 was collected from ticket sales. How many of each type of tickets was sold? So the first thing we have to do is we have to decide on some variables. So you can use X and Y, you can use a letter that's more, connects a little bit more to what we're doing. So for me, I'm going to use C and I. C for the number of couples. Well, couple tickets that were sold. And I'm going to let I be the number of individual tickets sold. That's what I do not know. So that's always the first thing you should do. You should identify your variables. And most of the time you're going to be able to see this in our very last sentence. How many of each type of ticket was sold? That's what I don't know. So C for couples, I for individuals. Again, you can use X or you could use Y. So the next thing to do is to figure out what we have total. We know that there was a total of 250 students that attended the dance. So we can write an equation knowing that there were 250 people in total. Well, we know that a couple's ticket gets in 2 people. So 2 people for every couple's ticket. Plus, our individual ticket only gets in 1 person. So notice everything matches up. 2 people, 1 people, 250 people. Now our second total is this dollar amount, $1,500. So that's what it equals. And money has to go with money. So a couple's ticket, whoops, now you put a C there, that should be an I. Sorry about that. A couple's ticket cost $12. So we're going to have 12C. And an individual ticket cost $8. So we're going to have 8I. So here is our system. And you don't have to put the 1 in front of the I. You can if you want to. But now that we have our system, we're going to solve it just like we did before. So the best variable to solve for is the I. Okay, so what I want you to do is I want you to take a moment now and go ahead and solve this out. When you're ready, turn the video back on. All right, number 8. Hopefully you're ready for your answer. If not, pause it and finish up. Here is the answer to number 8. So, you should have got C equals 125 and I equals 0. Now, if you didn't, double check your work. I noticed I solved for the yellow I, plugged in, and solved. Now, some students on a problem like this try to give me an answer like this. Do not do this. Okay, this is a word problem, which means there's units attached. Also, the variables depend on what you chose. If you chose X and Y or some other letters, your point may not look like my point. So what that means is we have to actually write down the answer to the question. So the problem says, how many says how many of each equation, how many of each type of ticket was sold? That's what we have to answer. How many of each type of ticket was sold? So the C we said was the couples ticket, so that's what we have to say. 125 couple tickets and 0 or no individual tickets were sold. That should be the final answer. Okay, do not just do it as a point. That only works when it's a skill problem. This is a word problem. Now, the other thing you should be doing with your word problems is checking for reasonableness of your solutions. Is it reasonable to have 125 and 0? Well, yes, it is. Logically, it's cheaper to buy a couple's ticket. So if you're going to buy a couple's ticket, you might as well find a friend that goes with you. Now, some answers that would not be logical are negative values. These are tickets. Fractions or decimals. You're not going to purchase part of a ticket. So if you're getting those odd answers, you definitely want to go back and check what you've done and make sure you've done it correctly. There's no way to check for sure your answer is correct, but there is a way to use logic to make sure it's at least reasonable. Okay? You could see if you do 12 times 250 and 8 times 0, if it equals 1500, again, logic, and you can see if that gives you a total of 250 tickets. Okay? So, or 250 people, sorry. Number 9. It says, last year you mowed grass or shoveled snow for 10 households. You charged $200 a season to mow a yard and $180 a season to shovel snow. If you earned $1,880 last year, how many households did you mow and how many households did you shovel? So, first thing we need to do is we need to decide on some variables. So, since we want to know how many households did you mow and how many households did you shovel, I'm going to let my M be the number of households mowed, and I'm going to let S, it's a cursive S, be the number of households we shoveled. Okay? So what I want you to do is I want you to see if you can create an equation using these variables. When you're ready, turn the video back on to check your equations, and then I'll pause it again and let you solve it if you've got the equations correct. So go ahead and pause now. So the equations for number 9 should be M plus S equals 10, because you have so many households mowed and so many households shoveled for a total of 10 households. And then your second equation should come from the cost. It costs $200 for the mowing, $180 for the shoveling, and that gives you a grand total of $1,880. So if you did not get the correct equations, go ahead and correct them now and then try to solve it now on your own. All right, so the answer to number 9, you should have gotten that you mowed 4 households and you shoveled snow for 6 households. Okay, again, make sure you actually attach your units, interpret your answer the question. It did ask you how many of each, so you need to say how many of each. So here's the work. Make sure you got it correct. Some little errors that you might have had is subtracting 2,000. If you tried to add it over, you would have gotten something kind of a crazy answer. And then you could have also solved for M or S, your choice here. Okay, so that is number 9. Let's go over to number 10. And I want you to try number 10 all by yourself. Pick whatever letters you want to use. Try to solve it out. All right, if you're ready to see the actual system, here we go. So the system should look something similar to this. You could have used X and Y. I used P and B. So P plus B equals 3 because one slice of pizza and one bottle of water cost $3. 3 slices of pizza and 2 bottles of water cost $8. So if you did not get this system, see if you can figure out what you've done wrong, and then go ahead and solve it from here. And again, pause the video. All right, the answer to number 10 is going to be that a slice of pizza cost $2. Now notice I did not include the bottle of water in my solution because all they asked us back up here in the problem was how much does a slice of pizza cost? So they don't care about the cost of a bottle of water. So the slice of pizza costs $2. Again, it does not matter which variable you solve for, P or B, or if you used X or Y, it really doesn't matter either way. As long as you know what your variable stands for, which is why you should always define them, and as long as you've solved correctly and made sure your answer is reasonable. It is reasonable to think that a bottle of water is $1 and the pizza is $2. That adds together to be $3. Likewise, 3 pieces of pizza, that'd be $6. 2 bottles of water, $2, $8. It's logical. So always make sure your answer is actually going to make sense to the problem. Okay, so make sure you have all your notes down. If you have any questions, write them down so you can ask me tomorrow. And then this is going to go in the notes section of your notebook, and then make sure you get your homework, show all your steps. It will be due tomorrow.